Okay, let's go back. Let's go back to the training. And the next part we will introduce about the BGP features. BGP is also another widely used routing protocol in our network, and BGP has a lot of path attributes, but we will not introduce the attributes in this course because we have introduced the detail about all of the attributes on the HCIP core course. So core technology course. So this slide is only introduce some other features about the BGP, such as the route control and for the peer group, for the BGP security, the networking, and others. So so after complete of this course, I hope you will be able to use the regular expressions when configure the S-path filter and the community filter to do the BGP control, and can apply the OFF and peer group function of the BGP, and know the basic configuration of BGP security, know the concept of 4-byte AS number, and can describe the networking modes of BGP RS, the route reflectors. Okay, the first part is about the route control, and BGP route control involves controlling the advertise and acceptance of the route. So let's see the scenario of this page. As shown in the figure, the R1 directly connect to three networks. They are the net 1, net 2, and net 3, and the R1 and R2 are reside in the AS101, and R3 and R4 are in the AS102. And R1 and R2 are established on IBGP relationship, and these two are established eBGP relationship. And R1 advertise these three routes to the three subnet to its BGP routing table, and R2 can, if we do not do any route control, it will receive these three kind of routes, right? So if the R2 do not want to receive the net2 route, it can do the filter. It can filter out the net2 route, or it can, for the R1, it cannot send this net2 route, or for the R2, it will not receive this route. So you can do the route control false here. And for the R3 and R4, they will receive all of both of the net 1 and net 3 routes, right? And for the network about the AS102, and when the device on the AS102 want to connect to the net 1, it want to choose the R3 as the egress device primarily. And when it want to connect to the net 3, it will choose the R4 for the egress device primarily. So this scenario, you can also do the route control for the route selection. So this is the BGP route control. And for the BGP route control, there are some methods you can use the route matching tools to match specific route, such as the ACL, the IP prefix list. We just talked about it before. And you can also use the AS-path filter and a community filter just to match the path attributes, such as the S-path and the community attribute on the BGP route. So these two kind of matching tools we will introduce this course. And then you can use the routing path tools to filter out these matched routes, such as the filter policy and the route policy. Okay, so for the first part about the BGP route control, we will introduce the AS path filter and the how to use the AS path filter and the community filter. Before introduce these two filters, we will introduce the common tools. We call it the regular expression. It's the regex. The regex can match some common or special characters to match the specific root. For the common characters such as the uppercase, the lowercase letters, the digits, the punctuations, and special symbols. And for example, this is the example for the letter A. It can match the A in the ABC, and for the regex 110, it can match the digit 10 in this IP address, and also you can match this symbol at in this string, and also you can use some special characters to match the specific root or to match the specific string. And there are 3 tables for the special character. The first tab is the first table. For the dot is match any single characters, and for the caret it matches the start position just of the caret string. It means if the character with 10, that means your string must be start with the 10. And the dollar is just the end position of the character string. And then is the underscore. The underscore is match any separators such as these letters, and also you can match some digits. And for the pipeline character, it's just a logic O. That means X pipeline Y. That means you can match the X or Y, one of them. And for the backslash, you can is used to mark the next character as a common character. And this is type 1. And type 2 is this 3 for the asterisk. The asterisk matches regular expression that is follows 0 or multiple times. And the plus is just for follow once. It will appear once or multiple times. And for the question mark, it will the following character will appear 0 time or once time. So this type is match the character to appear times of the characters. And the third type is about the bracket. And a bracket XYZ, that means you can match any characters contained in this bracket. That means the bracket 1, 2, 3. That means you can match one of them. Because for example, you can match the character 2 in the 255. You can also match the 1 in the 315. You can also match the 103 on the 315. Okay, that means match any character contained in the in this regex. And practice with the caret. That means you need to match any characters that not contained in this regex. So this means you need to match any character except the 1, 2, 3. For example, you have a string 4, 5, 6. You can match it, cross it, do not have the 1, 2, 3. All right. And the next is the practice with A-Z. That means A to Z. You can match any character within a specific range in a regex. Just means A to Z. So for the digit, if you use the 0-9, that means you can match any character 0 to 9, just from 0 to 9. And this also is beyond the range. That means you will match any character except the 0 to 9. Okay, so let's do. This is some task to do some example. For example, for the type 1, we use this. This is the caret A. $. That means you will match a character string that start with the character A, start with A, and end with any of characters. So because the dots match any character, so you can match the A1, A0, AX, and so on, right? And for the type 2, we choose the second one. For example, the ABC plus D. That means the plus means the C will appear once or several times, right? So the ABC plus D, it means it will match the character C once or multiple times. For example, it can match the ABCD. It can match the ABCCD, ABCCD, and so on, right? Because the C will appear once or multiple times. Okay, and the last type, we choose the last one. For the last one, the first bracket is 1, 2, 3. So you can match one of the 1, 2, 3, and dot. That means you can match any characters. And the final part is you can match 7 to 9, one of the 7 to 9. So you can match the 1, 8, 7. You can match 2, 6, 9, and others, right? So this is we use the special character to match the specific strings. Okay, and how to use the regex to do the S-pass filter and the community filter. First, we will go through the S-pass filter. For the S-pass attribute, it is a well-known attribute for the BGP, right? All BGP routes must carry this attribute. Whenever it passes through AS, it will add the AS to the S-pass, just like this. For the R1, it will send the route, and the route will carry the S-pass 101. And for R2, it sends the route. The route will carry the S-pass attribute, add the 102 and the 101. This is the first one. This is the second one. And if the router on the AS 104 do not want to receive the route carried from the AS0, AS101, or the R3 do not want to send the route that originated from the AS101. In this scenario, you can just use the AS pass filter just to filter out the AS pass 101. So how to filter out? We can just use regex to match the AS pass attribute. So for example, if AS pass has 103, 102, and 101, and you need to match the AS number is 103. That means first you can change the AS pass as a character string, just like this: 103, 102, 101. And now you want to match the 103. That means this string is begin with the 103, right? So you can use this character to make this string start with the 103. Okay, and then you can use the 103 with the underscore. That means it can match any separators. So it can match. It will not end with the 103. It will with others as pass attribute, right? So you can use this and so on to match this as pass filter. So, and other special example for the first one, it matches the S-pass list that do not contain any S number. That is the match route in the local AS. And for this one, it match all or any routes. And for this one, it match the AS number 100, 101, 102, 103. Because it start with the 110, it start with 10 and end with one of this string, right? So it matches the number of this. And here it matches the number exclude the S number 100 to 106 because it starts with 10 and do not end with 0 to 6 and others. This is special. These radix we are always used in the S-pass filter to filter out the special AS pass attribute. And let's see another example. In this example, there are 3 routes will be sent to the R1. The first has a AS pass this, the second, the third, and R1 receive many BGP routes. And if the R1 need to apply a policy to the route carrying the AS number 101 in their S-pass attribute. In this case, you need to associate an S-pass filter with the radix to match the route regardless of the route prefix. Now you need to match the route that has the 101 as pass, right? So that means you need to receive only these two routes because they have the 101, but the third one do not have, so you will discard it. So you can use different radix to meet the different requirement. For example, if you use this one, that means you only match the AS101. So none of them can meet this requirement, right? And third, if you use this radix, that means you need to the 101 to be the end of the string. So these two will meet this requirement, right? So you can use this to meet this requirement. Okay, and how to configure the S-pass filter? For the basic S-pass filter, you can create. First, you need to create an S-pass filter. Use this command, and then you need to apply the S-pass filter on the BGP view, and just for the peer and for the import or export the route. And you need to use this command to match the S-pass filter you have configured. Just use this. And for example of the S-pass filter, if you want to configure the S-pass filter, so first you need to create the S-pass filter like this. Let's see the requirement first. The R2, this is the whole network R1, R2, R3, R4, and they are in the different AS, and all of them establish the eBGP relationship between both of them. And R2 transmit eBGP route to the R3. And among these routes, some are logically originated by R2, and some are created by other areas. So a routing policy is configured on the R2 to deny the route originates from AS101. That means it will not send the route from AS101. So you need to create a S-pass filter to deny this, to deny the route from here. So you can create the first one, S-pass filter, to deny the S-pass end with 101. That means the originate S-pass is the 101, right? So that means the route is created from the R1. And for the other S-pass filter, you need to permit, that means you permit any of other S-pass. So the first you need to create S-pass filter, and then you need to apply. And first you can direct reference. That means on the BGP view, you can just peer the eBGP neighbor and apply the S-pass filter. Export, that means you need to send this route to the eBGP neighbor, and then it will just use the XPath filter you have created. And the second way for you to apply the XPath filter, just use root. You can use the root policy. First, also you need to create the XPath filter, and then you can use the root policy. If match the XPath, you can pair the neighbor and apply the root policy, and in the export direction. That means it will not send the root originate from the R1. Okay, this is the XPath filter, and then you can check the information. First, you can check the XPath filter on the R2. You can display the XPath filter 1 that you just create. You have two rows. The first is deny the end with 101, and the second is permit any of other XPath. And second, you can check the all of the root that can match the XPath filter. You can find only the root from the R1 will meet this regex, just meet this XPath filter you just created. So this is the example for the XPath filter. And the next is about the community. Community attribute is also a common attribute for the BGP. It's an optional transitive attribute. It can identify the root with the same characteristics regardless of the root prefix and varies as number. That is, a specific community value can be assigned to some root so that this root can be matched against the community value instead of the network number or mask. So we can also use a community filter to match the specific community attribute to do the root control. For example, there are two kinds of roots sent from the R1 to the R2, and one is with the community 101:1, and another is without any community attribute. So if the R2 only want to send the second root to the R3, it can use a community filter to filter out the root who has the community attribute like this. So this is a community filter. And community filter, there are two types. First is a basic community filter, which match the community number or well-known community attribute. We will introduce the well-known community attribute next page. And for the advanced, you can just use a regex to match the community number. So the regex will be used here. So what is the well-known community attributes? I think all of you will be familiar with these four kinds of types. The first is internet. For the internet is all by default. For the internet, that means the device can advise this route to any BGP peer. And by default, all of the route belong to this community. And the second is no advertise. No advertise means the device do not advertise this route to any BGP peer. No export. No export means the device do not advertise this route outside this local area, this local AS. And the final is no export subconfig. That means the device will not advertise this route to the other sub-AS in the configuration. So this is the four kinds of well-known community attributes. You can also use the community attribute configured by yourself, and the format is like, as usual, the format is like this. The AA:NN. The A indicate, as usual, indicates the AS number, and the NN is a useful defined number. So you can configure the community attribute by yourself. Just use this format. Okay, so first is the configuration for how to how to configure the community attribute. First, you need to use the apply community. You can use the community number configured by yourself, or you can use the well-known. And then you need to advertise this community attribute to the peer. So you need to use the peer configure command to send this community attribute to the specific peer. And then this page is the configuration for how to configure the basic community attribute. And this page is for the configuration, how to configure the community filter. First, you need to create the community filter by the first. You need to create the community filter. First is the basic one. Basic one means you can filter the number you have configured, or filter the well-known community attribute. And the second is advanced community filter. For the advanced, you just need to use the regular expression, just the regex, to match the specific community filter. These two kinds of community filter you can create. And final, just to apply the community filter, use the if match community filter that you configured. Okay, this is some example for configure community filter. First is if you just configure one row for the community filter, and this group of community relationship is AND. That means you need to match a root with the first, the second, and the third all of the community attributes, because the relationship between them is AND. And the second is relationship is all. That means you create several rows, and for different rows the relationship between them is all. You can match any of them, one of them, to match the community attribute. And the final is match the root carrying communicated string with you just use the regex, just like this. The character means you are start with 1, 0. That means you will match the community attribute start with 1, 0, because you use the regex, right? And this is the advanced community filter. Okay, let's see a example. For this example, you need the R1 has advertised 2 network, and so it will advertise these 2 route to its neighbor. And first, and for the first route, you want to configure a community for it, just 101 colon 1. So you need to use the configure command to configure the community, just like this. You use the IP prefix to match the root, and when you match the root, you just apply the community for it. That means and then you use the peer neighbor advertise community just to advertise this root to the neighbor. So when the R2 receives this root, it will with the community attribute like this. And then when the R2 sends the root to the R3, it wants to add another community like the no export. So it also needs to use the IP prefix to match the root, and then use the apply community no export additive to add another community attribute, and then pair the neighbor and advertise attribute. So for the R3, it will receive the root with the 2 community attribute. And then and then how to use the common community filter. For another example, if the R1 has advertised 2 routes, and each route with different community attribute. One is 101 1, another is 101:2, and for the R3, it only want to for the R2, it only want to send the second one to the R3, so it can use the community filter to match the route and to deny the first route to send to the R3. So you can create a community filter to match the first route, and you can apply the community filter by use if match the community filter you have created, and then use on the BGP view you can pair the neighbor and use the route policy. Use it on the export direction, so it will not send this first route to the neighbor. So you can check the BGP routing information on R2. The R2 can receive two routes, and for the 10.1.1, it with the community 101:1 for the R2. But for the R3, it only receives the second route because the first route has been filtered out by the community filter. Okay. And all of this is about the route control of the BGP. And the next part, let's go introduce some other features about the BGP. First is the ORF. ORF is a prefix-based outbound route filter. That means for the R1, it will send off the route it has advertised. But for the R2, it only need to receive several of them. So this time you can use the ORF to select some specific route to tell the neighbor to only send the specific route that I needed, and it will not send any other I don't need route. So this is the function for the ORF. And for the configuration, you just use the you need to configuration a route policy based on the IP prefix to associate which is the specific peer, and then you need to you need to tell the neighbor what is the specific route that you need, and then you need to enable the ORF function just to enable the ORF capability. And for the receive, that for this router, R1 is and R2. R2 first need to tell the R1 I need some specific route, so you need to use the first command to do so, and then it will enable the ORF compatibility for the receive, because next I will receive the route. It will send to me, right? And for the R1, it also needs to enable the ORF function by this command for the send, because it will need to send the specific route to the R2. So first, the R2 need to configure the specific route, and second, both of them need to enable the ORF function. Okay. So this is the example of the ORF. Just like I mentioned, the R1 first need to specific the need to configure the specific route, and then it needed to enable the function. Oh, I just made a mistake. It will send means it need to send the ORF packet, not the route. For the R2, it need to send ORF packet to the R1 to tell the R1 I need some specific route, and for the R1, you need to enable the capability for the receive, because it need to receive the ORF packet, and then it will send the specific route to the R2. Sorry, I make mismatch for them. And then you can check the configuration about the ORF for on the R1. You can check the prefix. You can check the ORF prefix list that is sent by R2. R2 use the ORF packet to send the specific route just like this. And then you can check the BGP route information on R2. You can find it's on although I have 3 kind of routes, but I only send the route that you needed. So the R2 only have the route I needed. I just mentioned here. So this is the function for the ORF. And the next is for the BGP peer group. For the BGP peer group, it just set a group for some neighbors, for some peers that who has the same policies. And for this group, you can use not a specific neighbor. You can use a peer group to do some BGP configuration. And first, you can create a BGP peer group. And second, you can configure as number for the specific, just like to establish the neighbor relationship. And you can add some specific peer to the peer group. Just add, for example, for an iBGP peer group, you can some specific peer number for the R2, 3, 4, and add this neighbor to the group you have just created, and then you can just use this group to establish the neighbor relationship. And also you can specify the source interface for the iBGP to establish the iBGP relationship. And this is an example for the R1 and R2, they establish the eBGP, and for the R2, it need to establish the iBGP with R3, with R4, and with R5. And also for the R2, it need to send the route from the R1 to all of them. So in this scenario, you can use a BGP group, and first you just create a BGP group, and for the internal means you create a iBGP group, and external means you create a eBGP group. So now I create a iBGP group, and then I put these three neighbors in this group, and then you can just use this group to specify the connect interface, and then to establish the iBGP relationship. So you can display the BGP group in, and in is just you created the internal group, just this type, that means iBGP, and the member in this group has 3, just the R3, R4, and R5, and for these 3, all of them establish the iBGP relationship. Okay, and next part is for the BGP security. For the BGP security, there are 2 scenarios. For the first scenario is for the RAG router. For sometimes you may be establish a BGP peer with RAG router. So you will, and it will advertise some invalid network route to the R1, and R1 will also advertise this route to other routers. So for the R2, its routing table maybe saved some invalid route. And the second scenario is for the attacker. For the attacker, maybe send a large number of bogus BGP messages to our security routers. So for the specific router, the CPU may be, the usage may be very heavy. You may be use a lot of CPU, so it reduce the speed of the device working. So in these 2 scenarios, we can use the BGP authentication and the GTSM to generalize TTL security mechanism to ensure the security of message exchange between BGP peers. And the first is about the BGP authentication. For the BGP users, the BGP use the TCP. The BGP uses TCP as its transport layer protocol and considers a TCP package valid only if the source IP address, the destination IP address, the source port, the destination port, and TCP sequence number in the package are correct. And most of the preceding parameters in a TCP package can be obtained by a attacker without much difficulty. It's easy for the attacker to use the TCP parameters to send the invalid message. So to protect the BGP from attacks, we can use these two authentication. One is for the MD5, another is for the keychain authentication between the BGP peers to reduce the attacks. And for the MD5, it's easy to configure, and it generates a single password which can only be manually changed. And for the keychain, the keychain algorithm is complex to configure, and it will generate a set of passwords. And keychain authentication allows password to be changed automatically based on the configuration. Therefore, the keychain authentication is applicable to network requiring high security. So there are two modes of BGP authentication. And for the BGP GTSM, is just to configure the specific TTL for the IP package. So for example, the R1 and R2, they are our own BGP routers, and they have one hop, right? So the R1 to the R2 TTL is 2 file. If there is a attacker, it establish an IBGP with the R2, so it will send whenever it sends a message to the R2, it will go through this physical link, right? So the TTL will change to R file 4 for this message. So the R2, if it enables the GTSM function, it will check the TTL number. It only receive the number with 2 file, so it will just discard this message because the TTL is invalid. So it will discard it. So it protects the R2 to receive a lot of invalid message. So this is the GTSM. And this configuration for the BGP to configure the authentication. For the MD5, you can use the peer neighbor and use the password cipher or simple. And for the keychain, you need to use the keychain name to use the keychain algorithm to do the password. And this is the GTSM configuration just to it's very important for you to configure the valid TTL hops. And for the it's 2 1, that means the hop is 1. And if for like this, these 2 routers, the hop is 2. You can just configure the specific hops for the valid routers. And for the you can also configure the action for the GTSM when you receive the message for drop or pass. And also you can enable the logging function on all borders to record the log information. And this example, R1 and R2 and R3, both of them need to establish the IBGP relationship. And for the R1 to the first you need to establish the full mesh IBGP. And then you need to configure the GTSM. This is the example for GTSM. So for the R1 to the R2, they only have the one hop. So the valid TTL hop you need to configure to 1. And for R2 to the R3, they are same to the R1 to R2. So the TTL also the 1. And for R1 to R3, so they directly establish the IBGP peer. But for the traffic, it will go through the physical link. So it will go through like this. So the hop is 1 and 2. So you need to configure the valid TTL hops with 2. And you can verify the GTSM configuration. You can, for example, for the R1 to the R3, this is iBGP link, and you can find that the GTSM has been enabled and the valid hop is 2. And okay, this is for the BGP security. And next part is for the 4-byte AS number. As usual, we use the 2-byte AS number, just like AS101, AS, just look like this, right? And with the expanded of the network, the AS number also need to be expanded. So we can use we expand the AS number as 4-byte. And for 4-byte. And for the 4-byte, we will introduce the 4-byte number now. And first, we need to talk some related concept. First, the speaker. Speaker is the concept on the BGP network. The speaker is the neighbor between the two devices who just send advertise the BGP packet, and another is peer. This one is the speaker, that means it sends the BGP message, and another is the peer. The peer means my neighbor. It means the BGP neighbor. And new speaker is the BGP peer. The BGP peer can support the 4-byte AS number, and the old speaker is the BGP can only support 2-byte. That means it cannot support the 4-byte AS number. And new session means is the BGP connection established between the new speakers, and old session is the BGP connection between new and old speakers, or between the old speakers. So these concepts you need to know as first. And what is the format of the 4-byte AS number? We always write it as this x.y. And if you want to change the this 4-byte number to the integer format, you can use this. The integer format equals to x plus multiple 65536 and plus y. And so, for example, the 2.3, it just use this to change to the integer format, just like this. Okay, let's next part. Next part is about the 4-byte AS number is carried on the open message. For the speakers, they just exchange the open message to negotiate the capability for them who can support the 4-byte AS number. And for the open message, it has a field for my AS number, and this part is just 2-byte. So for the old speaker, it just use this field to carry the AS number. But for the new speaker, it cannot contain the 4-byte number because the length is too short. So for the new speaker, it will change this part to a fixed number for the AS chance, and then the value is 2, 3, 4, 5, 6, and it will put its 4-byte AS number to the optional parameters. And BGP want to support the capability, the 4-byte capability. So it uses a new capability code and a new optional transitive attribute. And the new transitive attribute is like there are 2 attributes such as AS4. We have the AS pass attribute. Remember, we just talked about it on the AS pass filter and enable to, because it wants to support the 4-byte AS number, it add 2 new attributes. The first is AS4 pass attribute, and another is AS4 aggregator attribute. So these two attribute is used to support for the 4-byte AS number. So next, let's check the fundamental of 4-byte AS number. First, this is our whole network. There is some old speakers also have the new speakers, and first they will exchange the open message to negotiate the 4-byte capability, and then they will establish the BGP session. For the new, between the new speaker, they will establish the new session, and between the old speaker and the new speaker, they will establish the old session. And then for the new, between the new speaker, they only use the AS pass attribute to contain in the update message to transfer the S pass. But for the old speaker and the new speaker, they will use, the new speaker will use the S pass 4 as 4 pass attribute to send the 4-byte S number to the old speaker. So next, let's see the detail about the transmission. This is the whole network. The old session, the new session, the old session, right? First, for the old speaker, it will send the route with the S pass, just like itself, the 65001. And when the new speaker receives it, it will also, because each connector is also a new speaker, so it will only use the S pass attribute to contain the first S pass and the second S pass. And when the third one receive this attribute, it needs to send to the old speaker, but they establish the old session. That means next hop is the old speaker, so it needs to use the AS4 pass to contain the 4-byte S number. So it changed this part as 2, 3, 4, 5, 6 in the S pass attribute, and put this 4-byte S number on the S4 pass in the update message, and send these 2 attributes to the old speaker. And for the old speaker, and for the old speaker, it will send the message to the new speaker, right? And the new speaker can recognize the S4 pass attribute and also the S pass attribute. So for the old speaker, it will put itself as number on the S pass attribute, and also will directly send the S4 pass attribute to the new speaker. And when the new speaker receives it, it will combine these 2 attributes and to this S pass. So the new speaker will recognize the S pass is from this one to this one to this one to this one. So this is the transmission for the 4-byte S number. And for the configuration, it's just the same as the 2-byte S number, just the BGP S number. And for the S number, you can use for the 4-byte, you can use the X.1 format to set the 4-byte S number. So this is the example, just BGP 1.1 to set the 4-byte S number. Okay, and the final part is about the networking mode of BGP RR. For the RR is the route reflector. I think you have just learned it before on the BGP technology details, and we just review some basic about the RR. for the RR, it will have some roles. First, you need to select some routers as the root reflector. And the root reflector is the device that will reflect the root learned from an IBGP peer to other IBGP peer. And an RR is just similar to the designated router, just similar to the DR of the OSPF. And some other routers, we call it the client. The client is the IBGP peer whose routes are reflected by the RR. The R will reflect the route to all of its clients. And between the client, there is no IBGP relationship be established. And the other devices is non-client, and the non-client is just the normal IBGP device that is neither an RR nor a client. And in AS for the non-client, just like this is R6 is also a non-client. So between the non-client, it also needed to establish the full mesh IBGP. So we use the R to reduce the IBGP relationship number. Okay, and there is also some rules for the RR to advertise the route. Do you remember? The first, after learning route from the first is the route learned from the non-client. The R will select and advertise the optimal route to all its clients. And the second, when the RR learns the route from a client, the R will select and advertise the optimal route to all its non-client and client except the one who sends the route to me. And last, if the RR receive the route from the eBGP label, the R will select and advertise the optimal route to all its client and non-client. So there's 3 rules for the RR to advertise the route. And next, let's see the networking mode for the R. The first is backup. You can to improve the network reliability and prevent a single point of failure from affecting the network. Multiple RRs need to be configured in a cluster, and routers on a forwarding path establish IBGP peer relationship with all RRs. Any of the RRs has complete BGP route. So in this scenario, we select 2 RRs, and they are the backup to each other. So when the client 1 receives the route from the eBGP, first it will send the route to all of its RR. So it will send to the R1. It will also send to R2, and I will not mention this part again. So first it will send the route to the RR, and when the RR receive the route from the client, do you remember the rule? It will send the advertised optimal route to all its client and non-client, right? So it will send to client 2, also send to the R2, and R2 will check the route. Oh, they are in the same cluster, so it will discard this route. So it also prevents loops. So the R2 will discard it, and then it will send to the client 2, right? So this is the backup networking. And another networking is for the match cluster. And for the multi-cluster, there are also 2 types. The first type is the multiple RR in different cluster, and they have the same network layer. And in this scenario, all of the RRs need to establish the full mesh IBGP. So both of them between both of them need to establish the iBGP relationship. And in each cluster, you need to establish the iBGP between the RR and all clients Okay, this is the first scenario. And the second scenario is the hierarchical RR. That means you separate the network in different clusters, and for the first cluster is the level 1 reflection. These two devices is the level 1 RR, and they just worked as the backup. And these two devices is the client of these two RR. And also these two client is also worked as the level 2 reflections RR. So in the cluster 2, this client 1 is also the RR for this client, and this client 2 is also for the RR of this client. So this is the networking for the hierarchical. And the final, let's see a example. To prevent the desired redundancy in RR-based architecture, it's important to properly divide an AS into cluster. And this is a networking that we have two AS, and we just configure one cluster. And the R1 and R2, they are worked as a backup. So when the R5 send the route to the R4 to the client, the client will send this route to all its RR, right? And then to the R1. And this is the and this two-way do the backup. And sometimes one time if there is a failure occurs on this link between the R4 to the R3, that means the route can only send in this way. Because you remember the R1 and R2 will not send the route to each other because they are in the same cluster. So although you have the redundant link, you have the backup link, but this link is not used for you in this scenario to send this route. So this is not the best way for you to do in the network. So you can separate the cluster. You can put the R2 and R1 in different cluster. So the R1 can when the R4 and the R3 link is failure, you can the R2 can send the message to the R3 through the link between themselves because they are in the different cluster. So in the real network, consider about the RR's level and consider about the cluster. Cluster is very important for you to think about the reliability of the network. Okay, that's all for the advanced BGP features. And next, let's do some quiz. The first, which of the following XPath value is matched against the IP XPath filter 1 permit with these regex? And first is caret. Caret means it's needed to start with this character, right? And dollar means it need to end with this. And the pipeline means you need to choose one of them. So the XPath is you need to choose 100 or 200. So it can against the XPath for XPath 100 or XPath 200. So you need to choose one of them. So the answer is D. Next, authenticate BGP peer relationship can prevent unauthorized BGP peer relationships from being established. That's true, right? You can use the BGP authentication to prevent the unauthorized BGP peer relationship to be established. And you can also use the GTSM to prevent to receive the invalid message from the attacker. Okay, And the final question is, in the backup RR networking of BGP, the master and the backup RRs discard the route reflected by each other to prevent routing loops. That's right. We just talk about it, okay? So this is right. Okay, this is all for the advanced BGP features. For the BGP is also a well-used routing protocol in our network in the large-scale campus network, I think. Or in the or if you have the very one network built by yourself, you always use the BGP to connect to the very one network between the campus network, right? And the BGP has a lot of attributes so it's very easy to do the root control. And we talk about a lot about the root control for the different attributes on our HCIP core technology course. And in this course, we only talk about how to use the XPath and the community attribute. Just use the XPath filter and the community filter to do the root control for BGP. And we also introduce some other features about the OSPF, about the BGP, such as of the ORF to receive specific route, and the BGP peer group, and the 4-byte AS number, and for the RR network mode. Okay, that's all for these two. That's all for the IGP and the BGP features. Okay, if you do not have any question, you can just take a rest for 10 minutes, and for 10 minutes, and the next teacher will talk about the next part for you. Okay, thank you all.
Okay, thank you.